Imagine you and your friends are keeping a shared notebook. In this notebook you all write down who owes whom money. Now, how do you all agree on what's written inside? You can't have one person just changing the records whenever they want. That wouldn't be fair. You all need a system, a set of rules to agree on every single entry. This agreement is the most important part of keeping the notebook honest and trustworthy for everyone involved. Without it, the whole system would fall apart, and no one would believe what the notebook says. This idea of group agreement is exactly what a blockchain needs to function. It's the foundation of everything. In the digital world of blockchain, this group agreement is called a consensus mechanism. It's a fancy term for a simple idea, a method for a network of computers to agree on the state of a shared ledger without needing a central boss, like a bank or a government, to tell them what is true. Think of it as a digital democracy for data. Every participant gets a say, and the rules ensure that the majority opinion becomes the official record. This prevents fraud and ensures that once a transaction is added to the blockchain, it can't be easily altered or removed by a single bad actor. It's a powerful way to build trust among strangers. So why are these consensus rules so important? Well, a blockchain is decentralized, which means no single person or company is in charge. It's a network run by many different people all over the world. This is great for security, but it also creates a challenge. How do you make sure everyone is looking at the same correct version of the ledger? The consensus mechanism is the solution. It's the rulebook that everyone must follow to add new information or blocks to the chain. It ensures the integrity and security of the entire network, making it a reliable and tamper-proof system for recording information. Without a solid consensus mechanism, a blockchain would be like a game with no rules. Anyone could cheat, and no one would know which score was the real one. Imagine someone trying to spend the same digital coin twice. A good consensus method stops this from happening. It makes sure that every transaction is verified, and that the entire network agrees on the order in which they occurred. This shared agreement is what gives a cryptocurrency its value, and what makes a blockchain a revolutionary tool for everything from finance to supply chain management. It truly is the heart of trust in a decentralized world. So, how does a blockchain actually reach this agreement? One of the first and most famous methods is called proof of work, or POW. This is where miners come into the picture. But these aren't people with hard hats and pickaxes digging in a cave. Instead, they are people or companies with very powerful computers. Their job is to solve a complex mathematical puzzle. It's like a worldwide competition where computers race to find a specific number. The first one to solve the puzzle gets to add the next block of transactions to the blockchain and in return earns a reward, usually in the form of new cryptocurrency coins. Let's break down what this mining process looks like. Imagine the new block of transactions is locked inside a digital safe. The puzzle is the safe's combination. The combination isn't something you can figure out with clever thinking. It's a random number that computers have to guess over and over again at incredible speeds. They take the data from the block, add a random number to it, and then run it through a special mathematical function. They keep trying different random numbers until the output of that function matches a specific target. It's like trying millions of keys in a lock until one finally clicks open. This whole process is called proof of work because the winner has to prove they did the computational work to find the answer. It's hard to solve the puzzle, but it's very easy for the rest of the network to check if the answer is correct. Once a miner finds the solution, they broadcast it to everyone else. The other computers on the network can quickly verify it. If the solution is right, everyone agrees to add the new block to their copy of the chain, and the race begins all over again for the next block. This work is what secures the network and keeps it running smoothly. This system is clever because it makes it incredibly difficult and expensive for anyone to cheat. To change a past transaction, a cheater would need to resolve the puzzle for that block and all the blocks that came after it, and they'd have to do it faster than the rest of the entire network combined. This would require an unimaginable amount of computing power, making it practically impossible. The work miners do isn't just about creating new coins, it's about building a secure and unchangeable history of transactions, one block at a time. It's a powerful, if energy-intensive, security system. Now, all that puzzle solving and proof of work uses a tremendous amount of electricity. Think about it. Millions of powerful computers around the world are running 24/7, all competing to solve the same puzzle. This has led to major concerns about the environmental impact of cryptocurrencies like Bitcoin, which uses proof of work. The energy consumed by the Bitcoin network alone has been compared to that of entire countries. This is a significant weakness. While POW is very secure, its high energy cost makes it less than ideal from an environmental and sustainability standpoint, raising important questions about its long-term viability. Another trade-off with proof of work is its scalability. Scalability refers to how many transactions a network can handle in a certain amount of time. Because a new block is only created roughly every 10 minutes in Bitcoin's case, the number of transactions it can process is quite limited. Compare this to a major credit card company which can handle thousands of transactions every second. This limitation, often called the scalability problem, means that during busy times, transaction fees can get very high and confirmation times can become very slow. This makes it less practical for everyday purchases like buying a cup of coffee. So we have a classic science trade-off here. On one hand, proof of work provides incredible security. The sheer amount of work required makes the blockchain extremely difficult to attack, creating a very robust and trustworthy system. It was the first method to solve the problem of reaching consensus in a decentralized way, which was a huge breakthrough. This high level of security is why it's still trusted by the largest and most valuable cryptocurrency networks today. It has proven itself to be a reliable and battle-tested foundation for digital value. On the other hand, the costs are significant. The environmental impact from the energy consumption is a major global concern, and the limited transaction speed holds it back from widespread mainstream adoption for quick payments. This has led scientists and developers to ask a critical question: can we have the security of a blockchain without the high energy bill and the slow speeds? This question has sparked a wave of innovation, leading to the development of new and different consensus mechanisms that try to solve these very problems and find a better balance between security, speed, and sustainability. In response to the challenges of proof of work, a new and popular alternative has emerged: proof of stake, or POS. Instead of miners competing with computing power, POS has validators who lock up or stake their own cryptocurrency as collateral. The network then randomly chooses a validator to create the next block. The more coins a validator has staked, the higher their chance of being chosen. If they try to cheat, they risk losing their staked coins. This creates a powerful financial incentive to be honest, without requiring massive amounts of energy for puzzle solving. Proof of stake offers some incredible advantages. The most obvious one is the dramatic reduction in energy consumption. Since there is no intense computational race, the energy use of a POS network can be over 99% less than a POW network. This makes it a much more environmentally friendly and sustainable option for the future. Furthermore, it can often process transactions much faster, improving the network's scalability. Major blockchain networks like Ethereum have already made the switch from POW to POS, signaling a major shift in the industry toward more efficient technology. Of course, no system is perfect, and proof of stake has its own set of trade-offs. One concern is that it could lead to centralization, where the wealthiest participants have the most influence over the network because they can stake the most coins. However, many POS systems have built-in mechanisms to encourage decentralization and prevent this from happening. Other new and exciting consensus mechanisms are also being explored, like delegated proof of stake and proof of history, each with its own unique approach to balancing security, speed, and decentralization for different applications. As we look to the future, it's clear that the world of blockchain is constantly evolving. The journey from the energy-heavy proof of work to the more efficient proof of stake and beyond is a fantastic example of science and technology in action. Developers are continuously experimenting to create consensus mechanisms that are faster, more secure, and more sustainable. These innovations are paving the way for blockchains that can support a global scale of users for all kinds of applications, from decentralized finance to secure digital identity, all while being kinder to our planet. The future of consensus is bright, green, and full of possibilities.